STP are conditions that indicate standard temperature and pressure. The standard temperature is 0 Celsius, which is equal to 273 Kelvin, and the standard pressure is 1 atm, which is equal to 760 millimeters of mercury. At STP, we have a particular volume for 1 mole of gas. If we have 1 mole of gas under STP, they will all occupy 22.4 liters. The only difference if we have different gases will be the mass. 1 mole of helium at STP will be 22.4 liters, but the mass will be 4 grams. For oxygen, it will be 32 grams, and for nitrogen, 28. All these balloons are 22.4 liters. So we can use this value at STP as a conversion factor. We could say at STP, 22.4 liters is 1 mole, or 1 mole is 22.4 liters. And we can design a problem around this, where we establish the units that are given and the ones that we want. We use a plan, and we use the 1 mole to 22.4 liters conversion factor, and then we set up the problem. So let's do a couple of problems together. What is the volume that 2.75 moles of nitrogen occupy at STP? So we have 2.75 mole at STP, so we could put mole here, so it will cancel out, and liters here. 1 mole, 22.4 liters. We do the calculations, and the answer is 61.6 liters. Let's do the other problem. What is the volume at STP for 4 grams of methane? This one is a little bit more tedious. We have 4 grams of methane. So the first step will be to convert those grams to moles. For that, we need the molar mass of methane. Methane has 1 carbon and 4 hydrogens. Each hydrogen is 1, so 4 times 1 is 4. So the mass of the molar mass of methane is 16 grams. So we grab 1 mole, 16 grams, so they can cancel out. And then we do the conversion from moles to liters. 1 mole, 22.4 liters. We do our calculations, and we find 5.6 liters. The last law that we're going to learn is the ideal gas law. The ideal gas law combines the 4 properties of gases that we've been studying: pressure, volume, temperature, and moles. And the ideal gas law is this one: PV equals nRT. P for pressure, V for volume, N for moles, T for temperature in Kelvin, and R is the gas constant. This gas constant has a value of 0.0821 liters times atmospheres over mole per Kelvin. It could also have other units if we use different units for pressure, like millimeters of mercury. This value of R or this value of R will be given for you. They are in the equation sheet that you find in the for the quizzes and the exams, and they will be provided. So don't worry, you don't have to memorize them. Let's solve a problem about using the ideal gas law. All right, so this problem over here, they are giving us the volume, they are giving us the moles, temperature, and they want the pressure. So we know PV equals nRT. The pressure is the question, so we're going to solve for pressure. Pressure will be equals nRT over volume. Okay, so now we are going to substitute the values. Pressure will be equal to how many moles we have? We have 2.86 moles. The value of R, will that be the one that has millimeter of mercury from the previous slide, so that will be 62.4. The temperature is 23 Celsius, but that needs to be converted to Kelvin, so we add this. So the temperature is 296 Kelvin. And this divided by the volume, which was 20 liters. We do the math, and we end up with 2,640 millimeters of mercury for the pressure.